everyone to today's ALASCA Tech-Talk. It's the ALASCA Tech-Talk number 30 already. For those of you who don't know me, my name is Ariane. I am Alaska's community manager and I am moderating these sessions. And the ALASCA Tech-Talks is a format that is initiated or hosted by the Alaska Association. The association is about developing open source technologies in the context of cloud infrastructures. And we also like to share knowledge, raise awareness on topics like open source and digital sovereignty. And for this reason, we have established the Alaska Tech Talks, where we come together once a month to discuss all things that are in the development of new technologies, innovative ideas, whatever there is. And this is why we're here again today. Please note that this session is being recorded. We will upload this to YouTube later, so you can rewatch or share, and for those who cannot be here today. All right, for the agenda today, we will start with today's Tech Talk in a few seconds, and we also have time for discussion. You can write your questions in the chat and we will answer them after the talk is finished, or you can just ask directly then. And then we will look at some news and events from our community, and then we will announce the new Tech Talk of November. For today, we had a change in the topic very last minute due to illness. I feel like everyone is sick currently, and so yeah, but we are very, very happy that Max and Stefan are jumping in today. Thank you so much for being here. Max Lamprecht is a lead engineer at Stackit, and Stefan Hoffmann is a DevOps engineer at Cloud & Heat Technologies. Stackit and Cloud & Heat are both members of Alaska from the very beginning, by the way. And so it's very nice to have you here. And they will be talking about improving connectivity during live migrations. And that is everything from my side. Who needs the screen sharing rights from the both of you?
That's Max.
I think I can take it over, yeah.
Oh, you already have, right? Perfect. Thank you. Then the stage is yours.
Let me, how can I share? Do I need to upload the presentation or can I just share the screen? Do I know that?
You should be able to share the screen.
Yeah, you do have the rights. So at the bottom, there should be the...
Ah, yeah, I found it.
Perfect.
So I hope you can see it now.
Still loading, but it's, yeah, now it's there.
Okay, then let's start with our presentation. So first of all, a small introduction, who we are. My name is already mentioned Max Lamprecht. I'm working since 4 years in the infrastructure department of Stackit. Stackit is the cloud provider established by the Schwarz Group. The Schwarz Group is known for its big retailer brands Lidl and Kaufland, and we from Stackit offer our cloud services internally to the company, to the internal Schwarz companies, but also to external companies, targeted mid-size companies, and yeah.
And I'm Stefan Hoffmann, like mentioned, from Cloud & Heat Technologies. We are a cloud service and infrastructure provider. And together with Stackit, we built the open source tool Yaook to deploy OpenStack, which is the first project of the Alaska Association. So what we want to show you today is we will show you the problem that got reported to us. As it turned out later, it is related to live migrations. We need to do a short deep dive into live migrations, how they are working. And then we'll look into how the debugging process worked. And in the end, we'll present a fix that is not so nice in the first place, and then we'll show a second solution that we will provide upstream at OpenStack. So the problem we got reported was that VMs wasn't reachable for a short time, around 60 seconds, and there was package loss. This was mainly load balancer VMs, and so that led to VRP failovers. This got reported mainly by other teams, but also by customers. And what all these cases had in common, this was about small VMs. And quite fast we found then out that this happened always when we migrated these VMs, as we use Yahoo, and Yahoo can do updates and changes of configuration for you. We have a lot of live migrations running. I guess when this came out, it was like either an OpenStack upgrade or some bigger config change that we wanted to roll out. So every node needed to be migrated, emptied. Yeah. And the nice thing was we could reproduce the issue, and then we could stop the live migrations for now, though that we first can fix the issue before we continue with updating the next hypervisors.
Exactly. So then after we paused everything to avoid live migrations and not further disturb the workload from our customers, we started with debugging the issue. First of all, obviously, we checked Launchpad or Garrett for similar bugs. We also found their reports, but mainly for the ML2 OVS networking plugin. Maybe to state, we use ML2 OVN in our Yahoo environment, and therefore we weren't able to find something directly. We saw upstream that there are options like live migration wait for with plug that got implemented for workarounds from older networking plugins or such as ML2 OVS, but they didn't help in our case already. Also, we had them already enabled from our past ML2 OVS setup and still find the issue. So afterwards, we started to browse the code and asked ourselves how do even live migrations work. So therefore, we do now a small deep dive into live migrations because from the first side, we explored the OpenStack components of the compute side, so the Nova components, and there we found out that the live migration is mainly split into 4 sections. At once, after the live migration got triggered, we have some pre-checks that are, for example, checking if or finding a hypervisor destination that fits for VM and do their pre-checks such as, is it the same architecture? Can we even live migrate between these 2 hosts? Afterwards, we have a pre-live migration section, which is about preparing the destination node, such as mounting volumes, creating port bindings, creating the libvirt and QEMU VM definition, and so on. After that is prepared, we start with the actual live migration, which is done by QEMU. So there happens the volume transfer if we have some local volumes, and the memory transfer. And afterwards, if that succeeds, we start with the post live migration, which is mainly the cleanup on the source side. So at once the VM tear down, and also the unmounting of volumes and removing the port binding. As we troubleshoot here and want to deep dive mainly into network related issues with that the VMs lose network connectivity. For us, the main 2 important points are here. We have create port binding on the destination side and the remove old port binding in the post live migration, which are done by 2 post calls to the network API, which is the Neutron API. So after finding that out, it looked like a working setup for us, and we didn't thought that there are any problems. So we did extended our deep dive into the Neutron API. As stated before, we use OVN, where the main workflow is on the left side. We have on top, we have OpenStack API, the Neutron API, which receives all the API calls. and writes them on the one side in the MySQL database to keep track, and on the other side, the Neutron API will write it to the northbound database. The northbound database is an Open vSwitch database of OVN, which is like a logical representation of all of our network configuration. So which networks do we have, which routers do we have, and so on. Below that northbound, OVN has the so-called southbound database. There are more information about the actual physical networking layout. So we have the physical and logical informations and per node level information, such as logical flows, which compute node need to talk to which other compute nodes, where do we need VXLAN or Genève tunnels, and so on. And between these two databases, we have a NorthD, which is like a translation engine for rendering our logical content into a physical content. And at the end, all compute nodes have an OVN controller, which basically watches the southbound for new information, such as new flow information that is needed for that particular hypervisor, and writes them back to the Open vSwitch database, which then have the connected VMs attached and can do the routing and routing logic and so on. So each compute node has a watch on the southbound and gets notified by informations. So what kind of informations do we transfer here during live migrations? At first, as mentioned previously, we have these port binding calls, the create and the delete call. And at the end, the main interface on the northbound side, on the OVN side, is the logical switch port, which is kind of the same entry like in OpenStack, the virtual machine port. And during these bindings calls, we can see two important information on the OVN side. One is the requested chassis option, where we add multiple chassis during the initially setup of the live migration. So first, our active node is already written in there, and we extend the list of the information with a second compute node. Due to that, we set up a so-called multi-chassis binding in OVN. That means both compute nodes will now bind that requested logical switch port or virtual machine port. And beside of that requested chassis option, we also set a port activation strategy. We use therefore reverse ARP. This is needed for letting our network backend know if the migration is successful. The reverse ARP packages get automatically sent by the COIMO process after the successful live migration in order to notify all the complete network fabric that the live migration is now complete, and I need to send my traffic to the destination host or to the host where I received the reverse ARP from. Yeah. So exactly. After we have now these two options, we have binding on both VMs. And if now the controller on the destination side will listen for the reverse ARP packet and will capture that and will notify our rest of compute nodes that it's now active on our destination hypervisor. Also, that looked quite interesting for us, and also we didn't thought about that there are directly any issues, so the logic made sense to us, and we thought we need to go more deep and collect all timings, what happened during one live migration, where do we have, we thought first about, is our Neutron API slow, is the NorthD slow, are the controllers slow, or where's the delay of these 30 seconds of downtime that Stefan mentioned initially in the problem statement. So we decided to aggregate all of our logs and events, and collect them in a central place and check the timestamps of them. Here you can see a few events. These are not all events that are related to a live migration, but the most interesting one in our case. And here we can see we have a post request for creating the live migration on the destination side. We also have directly or 3 seconds after that in the northbound event with a requested chassis and reverse up entry on that logical switch port. We can see a few seconds after that the migration is now in progress and already the teardown is happening on the source node. Our ping stopped working, so we did at the same time a test ping to the VM to ensure and have also timestamps when it is working and when not. And after the ping stopped working, we saw directly that the VM got now resumed on the destination side. We saw in a TCP dump the reverse ARP packages that got sent from the COEMU process, and also the start of the post migration. But our ping was still down, so the VM was now started, but had basically no networking. A few seconds later, we then discovered that in the southbound database, we had that entry with a request chassis and reverse up. And after we saw that, our ping and our controller on the destination side first claimed the port, provisioned all logical flows, and our ping worked. So we can see now 11 seconds delay between the northbound and southbound. This is what we can see on the right. So we have northbound and the southbound, and in between the north D, and somewhere there is the delay of 11 seconds, which can be only the north D. So after that, we checked the north D logs on our side and discovered that we have reconcile times of 30 seconds, and also discovered that if a leader failover happened, that is something that they discovered later. If a leader failover happens of the northbound or southbound database, we see 90 seconds of reconnects and until we have the next iteration of north D reprocessing the networking information from the northbound to the southbound. And our big issue here is Nova, so the compute service, does obviously not wait for the port plug or flow programming that will directly move the VM to the destination without any networking or without that the network provisioning was completed. So we have now the VM on the destination side without any connectivity. And after the next North D reconcile happened, we have the flow information on the southbound, the compute fetches it, and the VM is alive again. Maybe to also explain some of the dimensions that we have with our northbound database. At Stackit, we have in the biggest database over 100,000 ports and over 5,000 routers. And it's mainly about the large content that we have in the northbound that needs to be translated to the southbound. That's also why the North D takes so long. In the North D, we have incremental processing engines that speed up the process, that not a full recompute of a few tables is needed. But these incremental engines are not yet implemented for everything. We contributed therefore it for BFD and NAT addresses, which was a main factor on our side for the slowness. We contributed it also upstream to OVN to improve the 30 seconds, but all of that happened later, and still we need to make sure that if we have a failover and so on, that we do the recalculation in time and do not move or start already for EMS on the destination node during live migrations that have no networking at all. Yeah.
So we wanted to check or need to check how a solution for that could look like. Like Max mentioned, we also updated OVN. So before it was version 23.9, I think, and now it's 24.3. And there was a lot of performance improvements of OVN already. In also some patches we built got merged there. So the improving OVN is not the bad way. That's good, but it's still not good enough. So I want to introduce you like a bad way how to fix that. What we can do, we saw in the beginning the different migration steps, or there at the pre-migration, we can tell NOVA to wait till OVN has done its part. Though for that, we need to create the tab interface of the VM by NOVA Compute. Normally that is done by libvirt when creating the domain on the destination. Though we need to tell libvirt here, it's fine that the port already exists. You don't need to take care of that. And to tell NOVA, it should create the port, the tab interface. And then NOVA Compute can wait till in the Open vSwitch database, there is a tag called OVN installed. That means the OVN controller has taken the port into account and applied all the flows. So then we can continue. So it's like a busy waiting there on the NOVA Compute side. And after that, we can continue. I did the fun and contributed that idea upstream. And of course, it got declined because NOVA does stuff there that it's not responsible for. Though the port creation and plugging by NOVA Compute shouldn't be done directly by NOVA Compute, but maybe by some library, and also checking for the status of the port and if it's in OVN. That is nothing that NOVA should do, but we have the information in the OVN controller, though that should come somehow from Neutron. So we now will show how a better solution will look like. As a short side note, this bad way fix is currently implemented on our side. It's also currently, I think, part of Yahoo. So this is a way that somehow works, but you really need to know what your storage network backend is. And it's no general solution. And of course, instead of having some patches by our own, we want to have a solution that is upstream. And I now present how this could look like. Right. So we start with NOVA again. There is a contract between Neutron and NOVA, and that says a Neutron does the network stuff and informs NOVA when everything is ready, so NOVA can continue. Therefore, there is NOVA has an event endpoint. So if I now call about events, it's actually an API call done by something else. But the Neutron can send and already has a mechanism to inform NOVA that network stuff is done and NOVA can continue. But this event is sent too early currently. It is sent as soon the transaction to the northbound of database is done. And as we saw, this is before the northd does the sync. So we only know OVN has the information, but we don't know if it's processed. So instead, we need to change Neutron that it sends the event when the OVN controller on the compute node applied the change. And luckily, Neutron has also some monitors to the southbound database. It has some watchers there. And there are already events that can be adjusted a bit, though that we send the event or that we check if the field additional chassis is set. That means, okay, the port needs to be applied on two hypervisors. And when the additional set, this means the change is applied on the controller. Though there is another field called requested additional chassis. That means please apply that. And when the additional chassis is set, then the OVN controller has the option set. Next thing is the changes at more or less the Neutron side. No, on the Nova side. So yeah, currently, like I said, libvirt creates a tab interface, and that is right at the time the migration starts. So that's too late at that point. The migration is already ongoing, and we can't wait for Neutron then anymore. So instead, Nova Compute should trigger the port creation via the OSWIF library. And Nova should build the libvirt domain in a way that the tab interface is not created. Otherwise, if the interface is there, libvirt will fail because it expects the interface should be there, should be created by libvirt, and the creation phase because it's already there. Yeah, and then Nova should wait for the event from Neutron. This mechanism, but then not the Nova compute anymore, but on another layer. This mechanism is already built in, but till some time ago, I think half year ago or so, Nova had opt out this check for OVN or for OVN backends because they said OVN is not reliable enough, or the events didn't came reliable enough from Neutron. But in the meantime, there was a lot of changes and version bumps at OVN. So now this whole thing is quite reliable, and they took in again that Nova waits for the event from Neutron in the OVN use case. Yeah, so that's already implemented, though we just need to take care of the port creation. Yeah, and that's already the solution. It's not yet implemented for upstream. I did a proof of concept of that and got some valuable feedback for that, but a proper solution needs to still be built as soon as I find time for that. Yeah, here we have some links for you. So the first one is a presentation about how live migration works on OVN, which is quite useful. And the second one is the tool that we use to see the transaction logs of the OVSDB. Maybe some friendly hint, don't run that on your production database file at the leader of your OVSDB, but take a copy of the database and do it then. Else you have some load issues maybe. Yeah, I think that's it from us. So thank you. Are there any questions? Yeah,
Perfect.
there's one by Kurt.
Yes, thank you so much, Ritu. Yes, there is a question by Kurt.
Actually, two questions, if I may. First one, this 30 seconds delay for reconciling data from the north database to the south database, is that like 30 seconds of computational time where you really need to process so much data so it takes so long, or is there some loop that just runs with a low frequency and that's why every 30 seconds or so it processes the data? That was
I
the first
think
one.
it's actually computing time, because it takes then in account the whole database and a lot of data. So that's an issue you only see in bigger environments, or in really big environments where you have a lot of data in your databases. So also upstream, no one saw that before, that behavior. They thought it's fine. Yeah, so.
Yeah. Maybe to explain it also a little bit more. So we in NorthD, we run it basically with 3 replicas, but only one replica is active at once, and the other ones are doing nothing and will take over if a primary or active NorthD instance is not responding anymore. But as Stefan already mentioned, so you have triggers that for the reconcile, such as, for example, a port change or an ACL change. And therefore you have engines that then, for example, if an ACL change, need to reprocess the policies, flow information, and so on, and render it to be southbound. And you have inputs and outputs, and depending on which input gets triggered, or there's a change received from the northbound, a few things get reconciled. But there are also inputs that would reconcile everything. So it depends always what happens on the northbound side. Or during the startup of the North-D, there's obviously also an reconcile of everything, which we can see by after a failover, for example, we can see these long downtimes or timings between reconciles. Yeah.
Okay, so I mean, it could get even worse if whatever the traffic, if the amount of changes on your northbound get more. Second question, and thanks for the great answer. I mean, you have observed now that Nova asks for that port binding to be created, and then it talks to neutron, then assume it's done. But in reality, it's not done, because like there's a async behavior, because there's this delay, while somewhere the assumption in the program was that once you talk to the neutron service, then it talks to the south, to the northbound, then everything's done. Did you find like more similar events where like you talk to the northbound piece of OVN and then you assume things are done, in reality are not? So I think there's a lot of potential for more misunderstandings like this one.
I mean, it's the same with just simple calls like an floating IP attach call. So if you do a floating IP attach to a server, the API call instantly returns, but you cannot directly SSH or ping the instance because you need to wait until it's processed by the SDN. So it's already for the user clear. So if a user does API calls, it's not directly 100% propagated through the whole SDN solution.
Yeah, but in that case, it's also the neutron API is not designed in a way that we could. Well, I mean, waiting the whole time till it's propagated through the whole system would be too long, and the API doesn't have some endpoint where you can check, is it now done? Or you could maybe rebuild the floating IP that you have some status also that is in creating also, and you wait till it's finished. But there's nothing like that there currently. Yeah, and I think also in cases like VM creation till the network is set up, that may take also some time, and you could run into the same issues. But there we currently didn't saw saw bigger issues with that the metadata agent is not there in time or so. So that
that is what we observed at some points, and there's also the difference between the OS. So some operating systems do a retry on the metadata side during boot, and some other operating systems don't have that retry built in. So that's also really bad if you start already the VM without having the flow information and without having the connection to the metadata service for the whole cloud init setup and so on.
Yeah, I mean, your VM is useless, obviously, if it cannot get the metadata service. Okay, great information. Thanks.
Perfect.
Are there further questions?
Yes. You can either speak up or write them in the chat. Both is fine. Just scrolling through the list. Okay, it doesn't seem to be the case. I'm sure if questions come up later, people can totally contact you and get in touch. So yeah, thank you again for this amazing talk, and also for jumping in on such a short notice. It was really nice to have you here. And with that, I would say that we move on with our other topics for today. Let me share my screen. All right, now I think you can see it. Yes, news and events from our community. By the way, I do not see the chat right now or any raised hands. So if you have something to say or ask, just speak up. This is all very informal here. But yes, we have, of course, an update or another call to registration from the Alaska Summit. And I believe Helena is here and can speak a few words on that.
Yes, hi everybody. As Ariane just said, I would just like to remind everybody one more time that the Alaska Summit is coming up on November 3rd and 4th here in Dresden, and we are very much looking forward to see everyone there. I think within the names, I'm recognizing a lot of people already who have already registered, so that's always great news and makes us really happy. So if you haven't registered yet, please do so. And then we have one more info for everybody who is coming into Dresden the day before. We do have a little bit of a get together. It's quite informal, just everybody getting together, having dinner at Augustina in der Frauenkirche. It's a restaurant and it starts at 7 p.m., but you can join anytime that you want. And we are very much looking forward to that.
Perfect. Thank you for the information. Yeah, it's very soon, so we will see everyone in person, which is something we are really looking forward to. Apart from that, October for us has, of course, been a lot of summit preparations, but I think one event that is worth mentioning has been the Open Infra Summit Europe in Paris just a few days ago. And as you can see, Alaska has been part of the open source pavilion, which is a really cool name, I think, together with the Sovereign Cloud Stack. And from what I've heard, it's been, a great event, a lot of talking about digital sovereignty as well. We've been able to talk about our open source projects that we are developing and, of course, about the SCS developments as well. And I don't know if someone wants to add to this, who's been there maybe.
It was, we've got a lot of questions regarding Yauk, what I was happy about, but didn't expect it before. So it was a really nice talk, and I'm good that we was there and could present Alaska and SCS there.
Nice. Yeah, that's great. And I think you also gave this talk at the Open Infra Summit, right? That you gave here right now?
Yeah, exactly. Yeah.
Nice.
Kurt, do you want to add something?
I mean, yeah, just echoing what you said, Stefan. It was really more people and more energy than the last summits that I remember. So also fresh people joining. And it was really good to see the energy in the rooms. I mean, we had sessions which were overcrowded. Actually, quite a number of sessions were overcrowded. Felt a bit like FOSDEM even, except that the place was much more organized. But yes, I mean, I really came back with a lot of energy and inspiration. So that was good.
Nice. That sounds very great. Thank you for the report from you who've been actually there. I think other than that, I don't really have many news or events. I still have the OSBA Connect as the save the date on the slide. I don't know if there is maybe an update or more info on that event. Or maybe if there are other events that you want to mention that you've attended or that are going to happen within the last weeks actually of this year.
Yeah, there's a few more events actually this fall. In the week of the OSBA Connect, there's the HICIT Summit in Munich, which has focus on digital sovereignty, which is kind of relevant to our community, obviously. The week after, there's CLC in Mannheim, and then in December, there's IT Tage in Frankfurt. So there's quite some conferences this year, actually.
Nice. Perfect. Yeah, so maybe we will see someone there. I personally don't have an overview right now, but yeah, a lot going on. So thank you for sharing that. Are there any other news that anyone would like to share? If not, yes, the year is coming to an end. We have exactly one Tech Talk left for November and are, of course, looking for speakers for 2026. I know that we do have some stuff in the pipeline already, but there are many, many open slots. So if you have a topic that could be interesting, something about open source technologies and developments that are related to cloud infrastructures, or something in this cosmos that we are active in, digital sovereignty, all of those important topics, feel free to reach out. It could be a full proposal, or if you just have a loose idea, we can also talk about that and maybe figure out a focus that could be interesting for this round. Just we always like if it's very, very technical. So yeah, if you know something, if you have an idea, always reach out. And with that, yeah, the last Tech Talk for this year will be November 28th with Martin Morgenstern from Cloud and Heat Technologies. Now, we didn't have the full title, again, due to people being sick. It's not easy currently, but it will be about developments in OVN. And we are looking forward to seeing everyone there. More info will follow soon. And I also am very sure that we will find a new slot for the original topic that is on the project within the NeoNephos organization. So this is still coming. And yeah, thank you everyone for understanding that this wasn't possible today. All right.
Ariane, as you mentioned that you cannot see hands and chat, maybe I'll interrupt you again. Sorry for that.
Perfect. Yes, please.
Actually, so Felix in the chat actually shared a link to the OSBA Connect. So there's like the schedule for that, so people can have a look and hopefully participate. And then also the pre-announcement for the SCS Summit in 2026, which is happening on May 21st.
Oh, yes. Write that into your calendars. That's important. Perfect. Nice. All right. Then I was going to say I will see you in the next Tech Talk, which I hopefully will, but a lot of you we will already see in less than 2 weeks here in Dresden at the ALASCA Summit. We are looking forward. Thank you again to our speakers from today for being here, and to the audience. And I wish you a nice weekend. See you then. Bye, guys.